Hello, and welcome to our presentation about the implementation of a vehicle tracking system. We are Team Electra, also known as Clean Code LLC, and we are Alexandra Alava, Luis Dominguez, Bo Wu, and Torrance Leon. The agenda for today is the following: background and boundaries, requirement analysis, design and code, testing and maintenance, and finally, a demo.
So now let's take a look at the background of this system. For small business owners, they need a reliable and easy to use system so that they can keep track of their inventory. Car dealership can benefit improve organization and efficiency substantially with a digital tracking system. Keeping an inventory that is easily modifiable allows for better tracking of each vehicle's status. There is a need by car dealership for us to design a system that keeps track of their inventory. This system must keep track of orders and the inventory. Tracking must be done for their stock of small and mid-sized sedans. Designing and developing the tracking system must be done within a 14 weeks time frame.
For small and mid-sized sedans, be designed and developed within a 14-week time frame. The requirements for a project are the following. 1. A system must be designed in which an inventory of the cars maintained and users can supply car information for usability. 2. The inventory should list cars along their type, make, model, and year. 3. There must be a way of adding or removing cars one by one from the inventory with information supplied by the user. 4. There must be a way to sell cars from the inventory with information supplied by the user. 5. There must be a way to look up the information of a particular car by information supplied by the user. 6. The inventory of the system must be kept in a CSV file. Now we're going to jump into the design and code. The first thing we face in here is on the left side we see the relationship between our inventory database and the actual tracking application. So we have to understand that the relationship between these two designs is the user input. On the right hand side we see the class definition of a car that has different data members such as the type, the make, the model, the year, and the count, meaning how many of that specific car with those characteristics is on the inventory. We also have the member functions, which are add car, delete car, sell car, search car, print inventory, get car index, and car exists. It is important to mention that the last two functions expressed in this definition are actually helping functions for the main function that we'll be using within our project. So to give a brief overview, our function add car lets you add either one or a batch of cars following all the characteristics that you provide for the four data members necessary. Delete a car will delete a complete batch of all the cars following or that fall under one specific characteristic or definition. Sell car would actually remove only one unit of the car you specify from the inventory. Search car actually lets you search for a specific make, model, year, and type of a car and let you know how many are there in existence for in the inventory. And print inventory will just give you an overview and show you every single car stash or car group that we have in the system.
More about our design and code. We developed in C++ 2017 to work in a familiar object-oriented environment, given that the structure of the problem lent itself for this type of development. We work with car objects that stored all of the information for each of the cars. Most functionality relies on accessors and mutators of the car class. This allowed us to modify, change, and add attributes to the cars easily. The live inventory that is created while the program is running is kept as a vector of car pointers. The CSV file is read as the initial execution. If there is no CSV file, the program creates a CSV file and populates the vector with this information. This vector can then be written by user's choice during the program execution. Testing and maintenance. For testing and maintenance, we tested the code both in Linux and a Windows environment. There were no instances in which program breaking behavior was encountered. The vector container currently allows for an indefinite amount of cars. This could be reworked to account for real-life physical limitations, but it was left like this for testing purposes. This allowed us to extensively test how many cars can be added, how many cars can be written to the file, and how long it takes for the file to read and write these cars. Maintenance of the systems is very straightforward. A CSV file format must be preserved to avoid problems in the database. Moreover, adding new functionality is easy to the modularity aspect of the program. There is little interdependence between the modules.
Here's the demo for the vehicle tracking system. We see that the program elegantly handles the CSV files with improper formatting. It brings the user's attention to these issues, and the user can decide whether they want to fix the CSV or ignore the bad formatting. The program is designed to ignore these errors, so we can jump right into using the program. First, we can print the list of all the vehicles within the inventory that are being tracked. We can also sell the cars, and it removes the car as expected because there is only one of these Ford F-150 2016 in the inventory prior. Adding a car batch is a simple affair of typing in the correct properties. We can then see these additions reflected in the inventory. We can also delete all the cars with specified properties. As we can see, the cars were removed from the inventory. We can also search for cars. Empty fields are treated as don't care values, so we can return all cars that match some or all properties. And lastly, we can save back to the CSV file so we can restart this later. As we can see, the program successfully wrote to the CSV and removed the ignored issues that we had prior.